Okay, here we go. We gotta kind of get going so that we have some time to work on this tomorrow. Okay, if you look at the assignment 2.7, I'm only giving you 6 problems to do for tomorrow. Obviously, they take a while to do, right? This is something you've never done before. The title is called More on Inequalities, so we're going to still work with inequalities, but we are working with bigger powers for inequalities, and we're also working with fractions with inequalities. This is the most important thing you have to do. You have to make a chart with every problem, and it's very time consuming. So far what we've done for inequalities was absolute values, correct? Hopefully you know how to solve that type of problem. Another type of inequalities we did was x is less than, let's go, x plus 2, which is less than 8, which is less than 4. Or we just had a basic problem like 3x minus 4 is greater than 8. So those are all the different types of problems we've done, and if you notice them, all 3 of them, degree 1, degree 1, degree 1. Why do we have to use charts now? Because it's going to be degree 2, degree 3, degree 4, and most importantly, fractions. So, here we go. We have 5 templates. You might have an extra one. I think it was blank. I just deleted it. So 2 minus 3x, this is baby step. This one's already kind of done for you. 4x minus 7 is greater than 0. It needs to be in factored form, and this one's already in factored form for you, which is kind of nice. If I put this back together again, isn't it an x to the second power type problem, right? Isn't it x to the second? So, how do we do this? This is what we do. For a split little second, you're going to change the greater than sign to an equal sign for just a split little second. And what you're going to do is, since it's already baby steps, it already helped you out, it's already factored for you in this problem, you're going to set both of these two parentheses equal to 0. Just for a few minutes, you're going to set those both equal to 0. I know the original problem is greater than, but right now we're just going to set both of the parentheses equal to 0, and we're going to solve for x. Negative 3x equals a negative 2. X equals a positive 2/3 for this one. The second one, 4x equals 7. X equals 7/4. Yeah, they're not pretty answers, but that's the way college algebra is. Okay, now comes this part. You're going to make a number line. I like putting 0, because I like knowing where it is. There's 0. 2/3 and 7/4. 2/3 is definitely closer to the 0 than the 7/4. Underneath the 2/3 and the 7/4, you're going to put a little a underneath here and a little a underneath here, which stands for the answers to the 2 problems that we just solved. And the letter is going to change in a couple of minutes, so that's why you need to put an a on here, which stands for the answer to the problem. Now I'm going to take this away because it's really greater than. Once you get your 2 answers, you're going to draw a huge vertical line through the answer, and you're going to draw another gigantic vertical line through the other answer. And you're supposed to see in this graph 3 different zones in this problem. And the bigger the problem, the bigger the zones. From a negative infinity to 2/3 is your first zone. From here to here is your second zone. From here to here is your third zone. And like I said, the bigger the problem, the bigger the zones, the longer it's going to take you to do the problem. What you're going to do after you make these huge vertical lines is you're going to have to test. You need to test the zones that you just made. You have to test your zones, and you have to put them back into the original problem. My first zone, I like picking the easiest number in my first zone, and my first zone has the 0 in there, correct? So I'm going to test 0 back in the original problem. And last year I went too fast, so I'll go nice and slow. Doesn't, if you plug a 0 in here, doesn't that wipe this out? So aren't you going to be left with just a 2 for that parenthesis, correct? 2. This one wipes out this 4 times 0 is 0. 0 minus 7 is a negative 7. So what's 2 times a negative 7? Negative 14. Is a negative 14 greater than 0 in math? Is a negative 14 greater than 0 true or false? It's false, isn't it? So this zone is false. The next number, between 2/3 and 7/4, you know a nice number that works in there? 1. Try to pick a nice easy number. You can pick any number between 2/3 and 7/4, but I'm going to try 1. 1 goes right here. 3 times 1 is 3. 2 take away 3 ends up being a negative 1 up there, correct? Again, I plugged a 1 right here. This makes 3. 2 take away 3 is a negative 1. I put a 1 here. 4 take away 7 is a negative 3. A negative 1 times a negative 3 equals a positive 3. A positive 3, is that greater than 0? Yes, that's a true statement. And the last one, what's a number greater than 7/4? That's almost a 2, isn't it? Isn't that almost a 2? So isn't 2 on the right side? I could do 2, I could do 3, I could do 4, I can use any number past the 7/4 marker. I'm just going to use 2. I'm going to do it over here. 3 times 2 is 6. 2 take away 6 is a negative 4 for that parenthesis. Again, I'm going to plug 2 in here. 4 times 2 is 8. 8 take away 7 is 1. Altogether, this makes a negative 4. Is a negative 4 greater than 0 in math? Is a negative 4 greater than 0 in math? No, it's not. This one's also false. So your answer to this problem is everything that it's true. And as you can see, it's greater than. There's no line underneath it, correct? So if there's no line underneath it, it's everything in between 2/3 and 7/4, not including these two because it's just been greater than. You can't use brackets, you have to use parentheses in this problem. It just so happens that it went false, true, false. Sometimes it goes false, false, true. Sometimes it goes true, true, false. It doesn't have a pattern, so don't think if it goes false, true, that this is automatically false on the test. Make sure you test everything. So why do we have to test everything? Because these powers are bigger than what we were doing before, and you've never done this before. If you took Mr. Kohutko's class last year, you did this in Mr. Kohutko's class, because I helped somebody last year making these wonderful charts. Okay, now we got some more to do. X plus 12 is less than or equal to x squared. Again, this is a pretty basic one. I'm going to, as you can see in the first problem, it was already factored for you. There was already a 0 on the right-hand side. We're just going to keep getting harder and harder. So this one, I'm going to bring everything over to the one side. I brought everything over to one side. Change my page here. The negative x squared plus x plus 12 is less than or equal to 0. At least I have a 0 on the right side, but there's something bad about this. The bad thing about this is I like factoring when this is a positive. So I'm going to multiply everything by negative 1, because you can do that. Whatever you do to one side, you can do to the other. I'm going to multiply everything by negative 1, so this is a positive x squared. This is a negative x. This is a negative 12, but be careful whenever you multiply by a negative number. You got to make sure you switch the sign. So be careful on that. And I did that because I don't like a negative. All I'm going to do is factor it. I'm going to put an x here, and I'm going to put an x here. Most of you know factors of 12, negative 4, and a positive 3. Yes, that gives me the negative 1 in the middle. For the time being, we're going to set these both equal to 0 and solve for x. Why we do that? Because that's where we start making our boundaries. X is equal to 4, x is equal to a negative 3. Again, you make yourself your little number line. Here's 0, here's about the 4 marker, here's about the negative 3 marker. No, I'm not putting a line through 0, that's just, I like having 0 on my number line. I'm going to put a gigantic vertical line through 4 and a gigantic vertical line through a negative 3. Very similar to the last problem. You can see that there's a zone 1, there's a zone 2, and there's a zone 3. Once you have your zones, you have to try those numbers back into the original problem. You can put it up into this problem. You could put it up into this problem, or you could put it up into this problem. Does it really matter which one you put it into? Are these all the same types, just transformed differently? I'm going to put it back up into this one. It really doesn't matter. A negative 4 is a number to the left of a negative 3. A negative 4 plus 12 is a positive 8. Is 8 less than or equal to a negative 4 to the second power? A negative 4 to the second power is a negative 4 times a negative 4, which is a positive 16. Is 8 less than or equal to 16? Yes, this is true. I like just putting a big T instead of writing out true. Obviously, the number between a negative 3 and 4 that I would use is 0. This should go pretty quick. What's 0 plus 12? 12. Is 12 less than or equal to 0 squared, which is 0? Is 12 less than or equal to 0? Nope. That is a wonderful false. And, or I should have put A's under here for answers. Forgot to do that. And I'll show you in a minute why that's important. And 5. Do you think 5 is going to work in here? Yep. 5 plus 12 is 17. 5 plus 12 is 17. Is 17 less than or equal to 5 squared, which is 25? Is 17 less than or equal to 25? That's also true. The answer needs to be the boundaries, but you got to be careful because in this problem there's a less than or equal to, correct? So don't have to use brackets in this problem. Final answer is a negative infinity to a negative 3 bracket union with bracket 4 to infinity. Final answer. We got 8 minutes, 9 minutes. I'm going to try to get through 2 more. I have to get through, now they're getting harder, obviously. Go back to the beginning again. I just talked about how to do higher powers, but how do you do fractions? We've never done fractions like this before. So, x minus 2 over 3x plus 5 is less than or equal to 4. Whenever you have fractions, this is new, I've already talked about, you'll have restrictions, correct? Whenever you do fractions, I've talked about restrictions before. There's something in math that you can never have in the denominator, and it's the number 0, right? You can never have 0 in the denominator in math. So, I'm going to put the 4 over 1, so now I've got a fraction equals a fraction. That's a good idea to do that, because then how can I solve this problem? By cross multiplying. Before I solve my problem, though, I'm going to go over here and figure out what my restriction is. 3x plus 5 is in the denominator. 3x plus 5, I'm going to set it equal to 0. Some people put the not equal to 0. I don't care if you do equal to 0 or not equal to 0. It's still a restriction. You cannot have a specific number, x, in there, else it'll make 0. And what is that number going to be? What the heck is that? 3x equals a negative 5. X equals a negative 5 thirds. That's not an answer to the problem. That is the restriction to the problem, right? If you turned out to be negative 5 thirds, you would have a nasty little 0 in the denominator, and that wouldn't be good. So that's called the restriction. This I'm going to cross multiply and actually solve. X minus 2 times 1 is x minus 2. um, less than or equal to, I'm going to cross multiply these two. I'm going to get 12x plus 20. I might only get through this one. I don't know. I have x minus 2 is less than or equal to 12x plus 20. I'm going to bring everything over to the left-hand side. Negative 12x, negative 12x. X take away 12x is a negative 11x. Less than or equal to, I'm going to add 2 to the 20. If I add 2 to the 20, I get 22. I'm going to divide both sides by negative 11. I'm going to get x. I'm going to change my sign to greater than or equal to negative 2. So, I'm going to make myself my number line. Here's, oh, we got lots of, here's 0. Negative 2 is farther down the line than the negative 5/3. So I'm just going to stick the negative 5/3 here. I'm going to stick the negative 2 here. Okay, now comes the restriction. When I solved the problem, did I get a negative 2 for my answer? When I solved it, right? This is the answer to the problem. This is a restriction to the problem. You have an A and an R standing for two different things. The last two were answers. This is an A and an R. You still only have one answer and you still have a restriction in this problem. And as you can see, you still have 3 zones in this problem. We still have 3 zones in this problem. And all I'm going to do is I'm going to pick my numbers to plug in, which that's the most time-consuming part, right? Tomorrow I'm not going to finish. I'm only going to finish this problem. Tomorrow, 5 zones you have to try. But this one, when you plug a negative 3 back into the where? Into the original. Negative 3 take away 2 is a negative 5. 3 times a negative 3 is a negative 9. A negative 9 plus 5 is a negative 4. This ends up being a positive 5/4, which is 1 and 1/4. Positive 1 and 1/4. Is a positive 1 and 1/4 less than or equal to 4? Is a positive 1 and 1/4 less than or equal to 4? Yes, this is true. Another number between a negative 2 and a negative 5/3. There's not a lot of numbers in between there because that's almost a negative 6/3, which is a negative 2. We tried a negative 11 over 6 last year, which is not a nice number. I'm going to run out of time, so I want to finish this. When you plug a negative 11/6 up there, it's not going to work when you put a negative 11/6 up there. You'd have to take a negative 11/6, take away 2 on your calculator, 3 times a negative 11/6, add 5 to it, and I'm just going to hurry this up. This is false. It doesn't work in there, and you can take the time and study how to check it if you want to, but a negative 11/6 doesn't work in there. I don't have my calculator here, but everybody knows, put a negative 11/6 here, subtract 2, hit the division button on your calculator, figure out what 3 times a negative 11/6 is, add 5 to it, take the two numbers, divide them out. The next number should be easy. I'm just going to use 0. I can show this one really quick without a calculator. Negative 2, 0 take away 2 is a negative 2. 3 times 0 is 0. 0 plus 5 is 5. Is a negative number less than or equal to 4? Yes. Okay, now I'm just going to show you how we write this and why the A and the R are really important to put on your graph. So, looking at this, the less than or equal to sign, this is a true statement. A true statement goes from a negative infinity to a negative 2 with a bracket there. A negative infinity to a negative 2 with a bracket there, because that's one true area. Another true area is over here, but you notice that negative 5/3 is a restriction. It can't be an answer, right? So you can't use another bracket. You have to use a what here? Parenthesis, because it's a restriction. A negative 5/3 to infinity. You only need to do the restrictions when there's a fraction in the problem. These up here did not have fractions. If you don't have fractions, these are automatically what? answers, right? There is no R. If you have no fraction, it's automatically answers. We have two more to do. This one's a very complicated one. It doesn't look like it, but it is. There's 5 zones in this problem. And then I have to do a story problem one because the story problem one is obviously going to be on the what next week? On the test. So we have 2 more to do. It's probably going to take me about 10 minutes tomorrow to finish this up. You'll have 40 minutes to work on your assignment, and you have 6 problems to do. I could have given you 15 problems, but I only gave you 6 to do, which was nice. It's the same. Get the notes even though you're, you got the.
I didn't get it.
Okay.